In this video, we're going to take a look at a few more topics, specifically abstract classes and virtual methods. Now, right now, all of our enemies are sharing this data. You can see here in our moss giant and in our spider, both of them call the attack method and it calls the shared method. What if we want the spider and the skeleton to use this attack method, but we want our moss giant to have a unique special attack method? It wouldn't make sense to create a new attack method down here just for me and say void my attack. Because what if there is something that I do want from here, such as the base attack implementation, plus I want additional code? This is where virtual methods come in. Virtual methods are going to allow me to overwrite the parent attack method, and I can still use the implementation here. To create this, we're going to say public void attack, and we're going to change it to be public virtual void attack. The virtual keyword is going to allow us to rewrite this implementation. Currently, if we run this, everything is still going to be as expected. The attack methods on the giant as well as the spider will get called, and debug.log base attack will be called. Now, for our moss giant, or more specifically, our moss giant and our skeleton are going to behave very similar, but what about our spider? Let's go ahead and overwrite this attack method. To do that, we would basically create our own attack method. Instead of typing out public void attack, we're actually going to use the override keyword. So we're going to say public override void attack. And what that's going to do is that's going to override the parent implementation. The moss giant and the skeleton will still use the parent implementation, but the spider is going to use his own implementation. So if we go ahead and say debug.log, this is the spider attack. Let's save this. And in void start, let's call attack. Save this. And if we go back into Unity here and run this, you'll see here that our spider is going to call its own attack because we're overriding the initial implementation, and our moss giant is still going to call its own attack, which is on the parent. So we'll play this. And you'll see here that the spider attack was called as well as the base attack was called. The moss giant called this one, the spider called this one. Now, what if the spider wanted some implementation details from the parent class? Well, what we can do here is before calling our code that's unique to the spider, we can actually type base, which will give us access to the parent class, which is the enemy, and I can then type base.attack. That's going to say, hey, run the parent code first, then run my unique code. So if you run this, you'll see here that base attack is going to be called twice now. Let's stop Unity and run it again. And as you can see here, we have base attack was called, and the spider attack was called. So the base attack was called first, followed by our spider attack, and then our moss giant called the base attack as well. So that is how the virtual methods and the override work. Now, this is also going to come handy when we create an abstract class. Now, the goal of this is that we want the enemy to define other enemies. When we create 50 enemies, we want to make sure that they have certain methods. So now what we need to figure out before we do this, though, is what methods are certain to be on each object. Each character is going to have AI between moving waypoints, which will be controlled through an update method. So we could force an update method on them. We could technically have the AI code all through this shared class as an enemy, but they're all not going to have the same AI. They're all not going to share the same waypoint. So one of the things that we can do here is we can say to them, hey, you must have this method so that you can control your own destiny for updating your AI. So one of the things we would do here is if we just type public void update, we can share this. If we type public void, if I say public void or public virtual void update, this will allow us to overwrite the implementation in my own script. So now if I save this, I can come into moss giant here and I can say, I can say here, public override void update. And what's happening here is it's optional, okay? It's optional for me to, and you can see here it automatically wants to call the base, but you can see here what's happening is it's optional. I had to optionally write the update method here. What if I wanted to force you, every enemy you create, you must have this method. It's not an option. You must have this unique implementation. Well, that's where abstract classes come in. So if we make this an abstract class, we can create what's known as abstract methods. So here we're going to say public abstract class enemy. And then here, instead of virtual, we're going to say you need to implement abstract method update. So here, public abstract void update. And you initialize it just like this. There's no implementation code. And what this is going to do is if I remove this, it's going to give me an error here because we're not implementing expected members. You'll see here that Moss Giant does not implement inherited abstract member enemy.update. To add the update, there's two options here. We can right click, go to quick actions and refactoring, and it will implement it for us. You'll see here that it's going to add a public override void update, and it's going to throw a new exception, which is just going to cause an error. So we can delete that. But what's important here is that it's requiring you to use that implementation. If you refuse to use that method, the program won't work. So what we can do is if we're going to have 50 enemies, we can ensure that these enemies are going to be built exactly how we want them to be built. So, and one of the other things to note here is I can't say public void update. This won't work. It has to override the parent object here. So here we need to use the override keyword so that we can make use of this. So we come back over here and we say public override void update, and that's going to solidify the terms. Public override void update, we save this, and if we come into here, we can say debug.log, we'll say Moss Giant updating, and now what's happening here is each enemy is going to have its own unique update that's unique to itself while still sharing the common traits of our enemy here. So let's go ahead and take a look at our spider here, and we need to do the exact same thing. It's missing the implementation details. So right now our spider is overriding the attack method. We'll go ahead and remove the base. We'll let it continue having its own attack method. But what we also want to do now is it's forcing an update method. So here we're going to say public virtual void update. And I'm sorry, not virtual, but override. Virtual allows a method to be overridden, and override is what we need to use so that we can take over the parent. Override. If we save this, now let's head back into Unity. Let's also add a debug.log here, and let's say spider updating. Now, not only do they all share common enemy code, but they all have their own unique implementations to void update. Let's go ahead and let Unity compile. Let's run our game. All right, and here we go. So if I clear, you'll see here that we have our spider updating and our Moss Giant updating. So now we can create unique AI code that's going to be specific to each individual enemy. However, if we look in the inspector here, they still have shared properties. Now, one of the things you'll notice here is that we can't see the shared members anymore. And the reason for that is because we made them protected. You can only see the variables if they were public. One of the things we can try and do is if we can add an attribute above them. So if we go back into our enemy here, we might be able to say serialized field, save this, and hopefully that makes it appear. And yes, that works. So here we just use the serialized field and you'll be able to modify these in the inspector. And that's ideally what we want. So inside our enemy here, we'll do that for all of them. That way we can individually define their traits through the inspector and not through the code. Okay, so that is going to wrap up turning this into an abstract class and working with virtual and overridden methods, as well as introducing abstract methods. If you are stuck on any of this, I highly invite you to check out our Discord community and ask your questions there to where you can get real-time explanations.